Darkness or I don't think we got all the but if we use the first approach, now it's not mine, but it's in general, and then see.
are professionals.
And so, would any group want to share some of the things that they found, like Ilse maybe?
What would you like, and what words we came up with?
More the strategy, not the particular words, but how would you approach this kind of problem? And to be fair, this is a problem that was motivated by some of my own research, or own work with some qualitative research. We try to understand how the effect of fear is presented, and that's actually, in my opinion, a pretty hard question, but I'm happy to hear your ideas.
Yeah, I have definitely the solution to it. Yeah, so we went off to SARS and we just looked for all synonyms of fear. And I think if you look for those words in the text, you get a pretty good idea when people talk about fear or when fear is mentioned.
But for example, if you have the synonym danger, you have in the text no danger. There is no danger.
Well, that's the problem with text analysis in general, though, right? But yeah.
That's what we discussed.
Okay.
How to control for such instances.
You don't hear.
Other groups maybe?
Basically, you can actually achieve even better results by including these cases in your training data. But still, as we discussed together, one can just come up with another tricky way of expressing that there might be or might not be any danger, and the machine will fail to capture sarcasm. Yeah.
Well, I need to say of sarcasm, because that's usually always said that, okay, for computer sarcasm is super difficult. We did some classification using 3 PhD students at University of Helsinki. I wasn't one of them, luckily, because I don't like to do classifications that much. So it was political tweets, and they needed to detect sarcasm out of that. We needed to remove the whole class because there was too low intercoder reliability on that measurement. And this was humans trying to understand that thing, but all of them didn't have all the contextual stuff about politics. They were political science and communication majors, so by all measurements they were experts on this domain and should have had all the knowledge to answer that, but it was difficult for humans also. But other groups, what are other ideas you have about fear? Yeah?
I think you have to start with the material. Basically, you would have to, if you have a large text analysis, you would have to start with coding the material to get the most distinctive words expressed in something that you, and it's very interpretive, what is fear, what is anxiousness, or something like that. So I'm using a dictionary to begin with. I wouldn't do that maybe. But if you would have to, then either you would have to have a material where people are expressing that you maybe ask them a question about, express how you feel a fearful situation, and then with that kind of material you could filter the most distinctive words and see how they occur in other situations.
Yeah. Any other ideas how to approach this? Yeah?
Well, actually we discussed that some phrases might actually reflect fear, not necessarily. So it's the words in dictionary might just give you some ideas, but it depends on the context you are trying to study, what relates. For example, even a simple word like "oh shit" might actually mean fear, because it depends on the context what the text is about. So we were thinking that beyond the normal words, it would be essential to understand what that context is, to understand even from the text analysis the fear of trying to combine simple words like captured. If you're reading kidnapped or this kind of words might actually reflect fear in that. So that was
okay. And I want to emphasize there's absolutely no one correct answer to this question. This is extremely difficult question that relates to the process of operationalizing quite a complex idea of an affect of fear into how does we present that using textual words. And that's not an easy task. It's extremely difficult. It is just more to get your thinking about this, but because I like these not that one. Because I like these things, I would want you to spend 5 minutes with the partner from other side. So if you were now on the right side, turn to the left side or something like that. and try to understand that we have an analysis where we have following words are seen often together. So our analysis says that quite often in Finnish media we see words gender, school, boy, girl, and pink together. And we need to give it a meaning. And to make this more interesting, figure out all the meanings that you can have for this kind of thing. And to be fair, this is a mock-up. It's not from real analysis. This is something that I had in my mind yesterday evening. But just like try to understand. And again, let's spend 5 minutes speaking with your pair.
So, yeah. What does together mean?
Isn't documents.
This is my iPad.
Well, maybe that way, yeah.
One topic is interesting thing.
That's all of those words.
And maybe how things
Oh, yeah, so if you don't know about Finnish media, just consider your home country's media. It's actually all the same. I don't care, it's a fake anyway, so you can fake more.
In the media, I see.
My sister wrote this article about this. My sister, what's more aggressive to this I don't know.
Or maybe there's less school side.
Paint your otherwise without asking or maybe it's like no boys room must be clothes and pinky. What project are you working Give us a kind of example. It's only you. How much you
But it's about dress code.
So, could we have some people who didn't speak last round to raise up some of the things that they were thinking that these could be? Anyone?
Maybe about the gender roles.
Gender roles, yeah?
The stereotypes.
Anything else?
For the age group is fairly young because it's boys and girls instead of anyone.
Anything else?
So we discussed about gender stereotype again, and also maybe T-shirts. Some people are talking about like you want T-shirt for some school activity. Do you need to have separate T-shirts for boy and girl? What color the T-shirt should be? So maybe for more T-shirts.
Yeah. Anything else? Yeah?
Probably happening in school.
What would be happening in school, maybe like?
Maybe this gender role, gender norms, maybe that's found in schools or...
So let's just add it there. Anything outside of gender roles? No one invented the reading of this that wouldn't be about gender roles, so then I need to spend a few minutes looking at it. Okay, I think that the year is a bit wrong, but this could be about Pink Panther, for example. It could be, and how kids laugh at that, both genders. Girls and boys like Pink Panther, so this could be a movie review.
But then Panther should be here as well, right?
It could be the sixth word. And this is exactly, you're right, like we should see that there, but because we are limiting our sample to 5 words, we don't know what was the 6th word. You need to be somewhat imaginative. You had some idea, yeah?
Yeah, we talked about that. Maybe we shouldn't say too much about 5 words, so if we could go one step deeper in the analysis and try to see how these 5 words are connected and somehow, or if we have some other metadata, we could make sense of these 5 words, because right now it's just 5 words.
Yeah. And why I wanted you to do this kind of exercise is that there's actually a technique that we are going to learn today, which is sort of produces this kind of word list quite easily. And then it's your task to try to give them a meaning. And as we saw, that can be a complicated task. There's, again, for this, there was no right or wrong answer. I do believe, like you said, there should be the Panther if it was about Pink Panther, but I needed to invent something just to say that this might not be from the most obvious thing that you were thinking that it could be. And that's actually like happened a few times in our analysis. We have 2 or 3 experts around racism in Finland going through some of these findings, and we are saying that, okay, this is definitely about this issue. Then we start reading through the material that's about that issue, and then we are like, oh shit, we didn't figure this one out. Yeah?
I think in the bit book there was also an example where they looked at, or I think recordings from pagers about what people said, and one of them always, they said, well, people were talking more about fear, danger, and so on, and one of the words they looked for was critical, because you say, okay, this was a critical incident, but then one of the pagers just had 500 times critical, issue, restart, boot now, so. And if you remove that, nothing happens anymore.
Sounds like usual computational or automated text analysis. So what I hope that these two examples showed you is that the step from conducting the analysis into linking it's something that we most likely want to speak about. We don't want to speak about, well, unless someone of you really focuses on linguistics. Linguistics want to hear about or speak about frequencies of words. I think that social scientists usually would want to speak about expression of the affect or the emotion of fear. And then linking that step into the fear thing takes some time. Similarly, if we want to speak about Finnish media discussion around gender or something like that, this could be something of that kind of thing, then we relate this quite easily into the discussion of gender roles in school environment or something like that. But then if that truly is about that, we don't yet know based on that. We sort of have this hunch, but it might take some more time to figure this out. And that's difficult because we always want to speak more about these kind of things quite often. We want to speak about the gender roles because we find that, at least I find that more interesting than saying that, okay, we found this really weird thing that has these kind of words, but then what the analysis give us is that kind of thing, and we need to make the connections. And the connections can be made in quite many ways, and sometimes more successfully, sometimes less successfully. But, as I said, so before conducting the analysis, you need to do some pre-processing of the data. So this includes, and we are going to go through them in more detail in the demo. So these are removing stop words. So there might be words that are not helpful in your analysis, like and, he, she, he, me, I. They don't usually give you any more information in your research questions. So stop words are research question specific. There are a list of common stop words that everyone uses, but then we might have some domain related stop words as well. But we remove those from the analysis because it's not helpful for us to know, for example, that the word T is the most common one in this kind of data set, because that doesn't tell actually anything that we are interested. Quite often people remove punctuation, numbers, make everything lowercase, stuff like that, to help them. So let's say that we have so we can all agree that the word cat with an exclamation mark, cat with a comma, and cats with a comma are about the same thing. They are about cats, but because they are different, this means that the computer doesn't figure out that these are the same words. So what we quite often do is that we remove the punctuation, like that, and then we also do something called stemming or lemming the word, depending a bit on what technique you use, which in English gets rid of these S's, and then they are all cats, or cat. And this means that when we are counting the frequency of cat, we are actually collecting this kind of different syntactical ways of showing that in the text, because they are all about the same thing, or we believe that they are all about the same thing. It's actually under discussion in the field if that happens. And then also quite often you need to transfer the thing from a text corpus into or from mass of text into something more meaningful, like a document term matrix or something like that. So document term matrix, for simplicity, is the kind of thing that I showed you before. So it has the documents, and then it has the different terms that are used. So there would be cat, dog, hello word, dominance, all the words in the document, and then in all of the documents, and then for each row, each document, it shows that how many times each particular word is there. So it's mostly a matrix that has lots of zeros in there. And then there's also something else called cleaning the data, and this is the painful time. So you need to remove extra spaces, you need to remove different kind of markups in the data, do all sort of cleaning like that, because the data is messy. Yeah?
Is there a clever way to do this, or do you have to like go through Word and delete all the S's and all the commas?
There's an easy way. And I'll show that in the demo. So there's one command that sort of removes all the punctuation, and then there's one command that removes all the extra spaces and all stuff like that. So yeah, this is mostly automated. Then there's even like to remove the most common English stop words, there is one command that makes it really easy. Then if you want to do something more difficult, maybe not remove particular things, then you might need to do something extra, but quite often you can survive with just running the simple thing of that. So I spent, actually this is the slide that I spent most time designing, which is trying to say that these computational methods, they are really cool and they are really powerful. You can get results in really quickly ways, but there are some things that are not that easy with these kind of methods, especially comparing with the like qualitative analysis that we started this slide with. And this is actually like super recent text, which spoke about different kind of pre-processing options for different texts. So this huge table here, each of these rows is a different way of pre-processing your text. So this row could be something that they decided to stem the words, they didn't remove punctuation, they did something else, didn't do something else, did something. I don't remember exactly, check the paper for the details, but these are different pre-processing options. And the idea is that every time that the system, so each of these rows is something like that. And these are different kind of documents that you have. You have label programs in that document, and then you have conservative programs in the document. And they wanted to do the different kind of pre-processing and ask that, okay, do we get this correctly if we start to use automated tools, one particular automated tools. In particular, so there's 228 different pre-processing options, like removing, not removing, removing, not removing, etc. And if that is correct, then it's white. And if it got wrongly labeled, then it's black. So you can see that here on the top, these kind of pre-processing things create text samples that are totally okay. So they get everything classified correctly. In the bottom, we are seeing pre-processing that gets most things wrong. And between we see different kind of variations about getting something wrong and something right. What's the core message of the authors that they show in quite many different ways is that pre-processing matters, because it has implications into what you want to do. So for example, if you remove stop words, everyone is saying that, okay, this doesn't really matter, but they show that it matters at some cases. So you get different results based on what kind of pre-processing you've done. And that's sort of why you should really consider when you are doing pre-processing that, okay, do I have theoretical justification to do something, or they actually in the paper present a package that allows you to test that does it actually matter if I'm doing some pre-processing or not. And if it does not matter, then you can be sort of happy that, okay, it didn't actually matter in the findings. So this is quite recent wake-up call in the field that, okay, we didn't know how does all the things that we are doing impact the stuff that we are seeing. Then something else, this is from Google. They've created, so Google has this kind of non-profit arm, and they've created a tool to measure the toxicity of the internet discussions. And I just started to test this out. So you can see up there is the toxicity score, and the higher it is, the more toxic it is. So we can clearly see that saying that things are not nice, it's not maybe that toxic. But then if you say that Canadians are not nice, that's a bit more toxic. If you say that men are not nice, it's not that toxic. If you say that women are not nice, that's extremely toxic. And this is to show you that just like it's the same thing with bit different words, and what most likely is behind here is that they are using teaching material from online discussions in US, most likely because it's from Google. So let's say that they are most likely seeing a lot more toxicity towards Canadians than Finns in US discussions, and therefore the computer learns to do that more well. It's able to say that, okay, I'm actually believing that this is happening. Similarly, online discussions, we all sort of know that there's a gender thing happening in the online discussions, even like really bad gender things, and that I think is seen in this kind of thing. That we have the same exact thing, but towards other gender that's perceived toxic, and towards other gender that's not actually that toxic. And what I'm trying to say here is that even if you start to teach some constructs like toxicity, so this is supervised learning that they've been using, and because they have actually really smart engineers, I believe that all the technical things are correctly done, but there most likely was some bias in the underlying data that then led into this kind of system. And of course, like the number differences are not that bad. Like we are speaking about less than 0.2 toxicity score differences there. So it's not a huge, but this is just to say that it's really hard to create systems that actually work and that you can classify correctly across different kind of domains. And in the worst case, you might create something that is somewhat discriminatory. So let's say that I would go to someone who's lawyer, and I would in US, and I would say that, okay, I want to sue the developers for this. I think that I would have a court case if I would just produce enough of these kind of examples, and I believe that this is a systematic difference. That would actually be so cool. I should maybe do that. And this is from my own research. Then, so this focuses on the exact question that how many topics you should choose in your topic model. But overall, this tries to say that one problem with machine learning methods is that the method doesn't warn you if you're doing something stupid. So you can ask it to produce, let's say that I want to produce 5 topics out of something. It will produce you 5 topics. If it's a meaningful 5 topics, that's up to you and only you and the peer review process to decide. So what I've done is that I've run the same material and just changed the number of topics quite a lot. And I even asked some of my colleagues to choose what they think is the best number of topics. They disagreed quite a lot. Juho was one of those colleagues in this process. And then here I'm taking, so different colors means different topics and the proportion of those topics, in particular time frames. And what you can see in these 2 figures, so this is from the same data, but they have different number of topics. And in Finnish political history, this time period is known as the chaos period. So there were new parties coming into Finnish politics, and that changed what happened in the party programs. There were more topics, or more novel themes discussed in these. And you can see that they are represented differently. In here you can see that these new colors have quite large share. In here they have somewhat smaller share. And something that I've been trying to question sadly, like one reviewer, so this is paper still in peer review, or it's actually now in my editing desk to be sent back to the peer review. So one of the reviewers said, this is the paper, like one of the reviewers said, this is the best paper I've read on, well, not the best paper, but he was like, okay, let's accept this with minor revisions and please read the language because I don't actually know how to write Finnish anymore. Then the other reviewer was like, okay, this doesn't make any sense, so I'm now trying to make the other reviewer more happy, but my core argument is that you can get the computer to do anything, and then you actually need to be careful because what you ask the computer to do have implications to your findings of your research, more or less. So I think that we could still survive a few examples and then let's take a break.
But can you go back to then, like how did you then decide the topics?
A number of topics. We used, so I'll send you the paper.
Yeah, it's really
so there's an English version of the paper also.
Maybe you can put it on Slack.
Yeah, definitely. Yeah. Yeah.
Thank you.
The number of topics for each column, right, is the same?
Yeah, so it was so that the green color here matches the topic of green color here. So they are supposed to be as close matches as possible. That's of course not always easy or trivial, but this is trying to highlight just the thing that it's really difficult to choose. And like my argument that I'm trying to make in the text, which one of the reviewers really figured out on the first round and the other one didn't, was that you can actually argue any of the number of topics that I've proposed throughout the text as the correct number of topics. And I find that disturbing, because then you start to have these differences in the findings, and therefore I propose that let's just use statistical optimization instead of doing anything else. But that argument still needs some time. Any other questions? So I wanted to jump into showing you how these kind of things are used in social science research. And I'm just taking one example of each of the three kind of things, so dictionary-based, supervised learning, unsupervised learning, and show something that's happening there. So yesterday when we were trying to find the paper that had the Twitter bot, this is from that paper. So this is the paper that tweeted for those who were using powerful racial slurs and tried to reduce the racist harassment in Twitter. And this is the process of what they were doing. So they had something like that, and that's the process. But what I find interesting, and why I would say that this is dictionary-based approach, is that they've chosen one particular keyword. And they say that this is a powerful racial slur. Of course, they could have more keywords to have more of that dictionary, but that's how they defined a powerful racial slur, is the using of that particular word only. So let's say that I would be using some other words. Sadly, I'm not that in US culture that I would know all the other words, but in immigration discussion in Finland, they are constantly chasing, so it was first mamu, so someone who's an immigrant, then it turned into matu, so someone who invades the country. And now I think that they are doing something else, and I'm not really following up the discussion, but they sort of define, so their construct of racial slur is this particular word. I don't know if it actually had stars in the search sentence or not, and they are not saying that in the paper. That's actually really confusing for me, but let that be. So, dictionary-based approach, example, used in real world, got really interesting results in my opinion. And then, this is something else from Syracuse University, something called Illuminating 2016, where they want to follow how different candidates like Hillary Clinton and Trump have used different kind of approaches in their speech. So are they using strategic messaging that's attacking someone else, or are they using advocacy-based approaches, or something like that? I think that the Clinton might not be the most best thing from here, but what they've been able to do is that they are able to show how candidates use different kind of approaches in social media for their campaigning. And for this I just wanted to show, so what's behind here is actually quite elaborative classification framework around different kind of things that are happening in campaigning. Like there is call to action, and there are ceremonial activities, and there's informative things, and attack and advocacy and stuff like that. And these are actually all drawn from existing research on political communication. I think it was on television shows or television ads or something like that. So that's why they've used a supervised model. They had people saying that I believe that this tweet is about attack, and then when they have enough people doing that, then they could produce this kind of actually real-time or nearly real-time visualization of the candidate activities. And of course now they are able to say something more general, like, okay, Trump used this kind of things, Hillary used this kind of things, this is what we are happening. This is, for example, what's the relationship of attacking in social media and your popularity in the polls or something like that. So they are able to do a lot, and it's all based on and I would say that it's actually all based on the fact that they've developed the classification framework from existing theories, which helps to do the binding between theoretical stuff and empirical stuff, or the like analysis tools, because their analysis actually correspond to something that we are seeing. And then here is the one last paper. It's about, again, this kind of analysis on different kind of things that people are addressing about US tracking laws. And what you can see here is, or what's the core message of these authors is that there are differences. So organizations address different topics. So this is about US lawmaking process. People are asked to write comments about the law, and these are analyses of those comments of the law, and those comments are coming from individual people, or then they are coming from this kind of organization, or maybe lobby groups or trade unions or something like that. And you can see that they are addressing different topics. So these individual citizens were extremely interested on these kind of, and I don't remember what these are, but they were interested more on these, whereas these organizations are clearly more interested about these issues here, and then they are about equally interested on that issue. There's a difference, but it's marginally significant. So that's sort of trying to show you what you can do with these kind of tools. They are pretty cool. You get interesting results out if you are able to get them correctly laid out, and everything is nice. So any questions of these examples that I quickly just showed you, with the idea that you would get some ideas on how you relate this with your real research? Okay, so what if we take a 15-minute break, and then we'll come back here? Yeah?
Do you think a lot of these visualizations can stand alone, or do you think a lot of them need more explanations? Not just to explain it, but to use your theory, or I mean, do you understand what I mean? Can the conclusion more or less just be a number, or do you?
I think that the field is shifting on that particular topic, I don't know if this particular field is shifting, but I'll speak more about network analysis where I've seen the shift. So in 2010s or 12s, it was totally okay to have a paper with the core contribution of that paper was a plot showing that this is what's happening in Twitter, like this is who's tweeting to whom. And now we are no longer seeing that, or at least I'm not seeing that paper, these kind of papers anymore. I think that everyone sort of got that, okay, these are all the same kind of plots that we are in the end producing, and they started to ask that what we need to do more. With the computational text analysis, it's a bit hard to say where we are moving at the moment, because this is, for some fields, this is something that actually, if I understood it correctly, for example, reviewers or other colleagues might not believe your findings anymore, because we sort of passed the first hype of these kind of methods that they can promise everything. But then in some other fields, that's like totally fine. So I'm myself writing few papers, like one of the many co-authors on those papers, that more or less just provide not a plot like this, not a plot like that, but just like list that these are the topics that we saw. And that's the core contribution of that paper. And we believe that that's strong enough contribution to make that publishable in that particular subfield and with that kind of framing. But in general, I do like more, and this is to return some discussions that we had on Monday. I do like when you are able to integrate those deeper into having something more interesting. So this paper is one of my favorite papers on topic modeling, because it's able to not just say that they found 8 different ways how people took part in this kind of legislative process, but also because they relate it into some attribute that's super relevant to the question that they are seeing and saying that, okay, this is really cool thing happening there, and or that we are seeing this happening, and I like this because this is much more interesting than saying that we have these kind of 8 teams. Like, who's interested about US tracking law legislation, really? Yeah.
My impression is that you also need a lot of space for validating whatever you got, like your topics and the amount of topics and so on. So do we talk about this also in more depth? Because that's quite crucial.
The challenge with validation and why I haven't spoke about validation is that there's no correct approach at this point of time. So validation means that once we have these kind of topics, for example, we have here topics or we have their topics, we should somehow say that, okay, what we are seeing here, or actually let's jump back into this. So this could be a result out of topic modeling process. So you later today learn how to create this kind of word list, but then the discussion that we had around the different kind of meanings, that's called like the validation step. The problem with the validation is that it's more or less ad hoc practice at the moment. Quite often it's that you just read a small sample of those and sort of confirm that these were the things that you were doing. It could also be something more mixed method kind of thing where you sort of do a smaller sample analysis with something else and then say that we find more or less the same kind of things. Or then I'm actually in some of the text that I'm writing about the results that I showed you, I'm making the argument that you can also validate using existing theoretical knowledge. So for example, in here, because we know that we should have more colors in this column than previous columns, and because all the plots show that there are more colors, they just show a bit different kind of number. So this is what we should expect to happen, so therefore it's not totally insane, because we can say that existing theories support this observation and therefore we can build on top of these kind of things. But I think that the problem with validation at the moment is that no one, at least to my knowledge, no one has the, like, this is the only way that you need to do your validation. Instead it's like, make your best argumentation around that, how you've validated, and the most likely people will not trash that. And we are still like waiting, I think, in the computational methods. I've been speaking that this is sort of a wild west at the moment, so you can do almost everything and just hope that the sheriffs are not there.
But that's very problematic because it's about the plausibility of the result.
Yeah, and that's sort of why many are hoping that we would be moving away from the wild west, including me, like that we would have some more standard approaches, standard ways to do things, and therefore we could, for example, say if someone is doing something non-standard, that okay, this looks a bit fishy, could you explain more why you've done something like this? But we are not yet in that, at least in the papers that I've been reading. And of course, again, different disciplines, different fields of social research, computer science move a bit differently on the whole validation things. Any other questions? And that was a great question, yeah, and I didn't elaborate why I left that out, but the reason is that I actually don't have anything clear to say about validation beyond that you just need to do some ad hoc thing, a trick that sort of
So coming up with a scheme would be a real contribution?
I feel so, and there are some works that have been trying to direct towards that thing. Why didn't I add anything of those here? That's a great question.
I just know this text of Primer and Stewart, and they propose for each different method some kind of validation technique, but it's still, it's in one article, so there's not much time.
And I think that the validations, beyond saying that you should really validate, if we are speaking about the same text, is it the Texas data or something else?
It's from 2013.
Yeah, so at least my reading of that is they don't really tell you how you should do validation. Yeah, they say exactly, like that's one of the subheading is that they say validate, exclamation mark.
Small examples, but it didn't really give me good examples.
Yeah,
of how I could
and I think that that's like they understand that we need to do validation, but they might not go in depth on that. And the validation that I've quite often seen is that you then take some, well, and that actually depends on the method. For example, for supervised methods, there's an easy step to do the validation because you've done manual classification. You test your best model against that manual classification and hope that you get nice results. For dictionary-based and for this kind of unsupervised models, I think that the question is more that you should check some of the outputs and check if that actually makes sense. So once you start reading,
small sample and qualitative.
Yeah.
Do it.
Or that seems to be the common practice at the moment in sort of unsupervised things. In dictionary-based things, I actually haven't ever seen people doing validation. There are some techniques how you can test if your dictionary is complete or not. But it's a complex thing. So, are we now ready for a 15-minute break? Excellent. Juha, please.